Welcome to the Documenting Information Systems Part 2 pre-class lecture. The reason I created this is that in class, in the next class we have, what we're going to do is roll our sleeves up and work through a problem and work through it in groups and learn from each other. And I didn't want to spend most of the class giving a lecture on physical and logical data flow diagrams. So I wanted to throw this up, have this be where you prepare the overview and the things that are in the textbook, and then we'll do examples in class. And this is a continuation of the prior lecture where we talked about documenting information systems, the various types of symbols that you have, doing an entities and activities table, and those kind of things that we covered in the last class. Let's start with a physical data flow diagram. And what a physical data flow diagram does, it shows the flow of data into and out of the external and internal entities. And the thing you've got with a physical data flow diagram, it shows you the where, how, and whom of a system, but it doesn't tell you what. And a logical data flow diagram will tell you what is happening with the system. One thing to keep in the back of your mind when you're doing physical data flow diagrams, the bubbles are nouns. And when we get to the logical data flow diagrams, the bubbles are going to be verbs. But for a physical data flow diagram, the bubbles are nouns. For example, as I put here on the slide, sales clerk, bookkeeping, ERP system, those are all nouns that are used as descriptors in physical data flow diagrams in the bubbles. And the thing a physical data flow diagram does, it depicts the system's infrastructure and the flow of the data between the entities within that infrastructure. We talked about in the last lecture an internal entity. Internal entity is an entity within the system that transforms data. And in this case, keeping with the nouns, accounting clerk, departments, computers. And remember, with an external entity, they're external of the processes. And then the other thing is, with external entities, they don't transform data. And we talked a little bit about that in the prior lecture. We'll talk about a little bit of it when we're in class, in the next class. But just to frame in your mind, an external entity does not transform data. So if you end up having an external entity, we're going to see a situation where you end up having a customer being an external and an internal entity. A customer can be an external entity if they just place an order online and that's it. They end up being an internal entity if they end up processing the data. And there's a back and forth and they have to approve or not approve or something like that. This is just a review of the symbols that we covered in the last class. A bubble is the entities. External entities are squares. Data stores, which are the little lines, parallel lines, and then the data flow symbol are the arrows. This is just a generic physical data flow diagram. And you can see what you have here is you've got your external entities on the ends. And remember, with a data flow diagram, you want to go from the top left, top right, top left. My left, your right. The top left down to the bottom right. You can see you start with the two external entities, and then you place your internal entities within the physical data flow diagram, and then put what the arrows having what the flows of the data are. So you can see here, and it's nouns. You've got cash register tape, verified register tape. Blue sales book is going to be a data bank. And then you've got here, goes to the cashier, internal controls to verify the register tape that bookkeeping does, and then the deposit to the bank. Physical data flow diagram, the labels should describe the means by which the flow is accomplished. And going back to here, cash register tape, deposit slip, verified register tape, that's where the labels describe the means by which the flow is accomplished. So I've got here customer order acknowledgement, record sales. Draw a bubble for each internal entity. We did that. and then first draw bubbles connected to external entities, and then move inward. And then you go through the entities and activities table and identify the internal entities. Draw them in a data flow diagram as well as the physical data flows between the external entities, which we have done. And the thing is, it starts with a narrative, and this is a narrative that I put in the slide on the previous class. And this slide is just the narrative that was copied out of the book, and then you copy the narrative over into a table of entities and activities. And entities and activities are where you go to look at what the internal entities are, and then to see what is the physical data flow that goes with those entities. And you can see here what has happened is that we have come through and marked what they are, put them in the logical order, and that's what we carry over into creating our physical data flow diagram. Let's stop for a minute and talk about a balanced data flow diagram. When I was putting this together, I kind of was trying to decide where to put this in the lecture, so I just put it smack in the middle. Balanced data flow diagram, what it really means is that if you have two data flow diagrams that are the same process, they have equivalent external data flows. So with the Saprina example, that's the example in the book, we have two external entities, credit card processing company, warehouse. So to have a balanced physical data flow diagram, any diagrams that are done at the zero level, as we talked about in the prior class, are going to have those same two external entities. Here are some examples of balanced data flow diagrams. You can see here we start with just the context diagram. You've got your two external entities. You expand it, and when you expand it and have a level 0 data flow diagram, and we cover context diagrams, which was a simple diagram in class, in the prior class, you go to the level 0 data flow diagram, you can see that it's balanced because of this. It's got the same external entities. You also are balanced if you have the same inflows and outflows if you're ended up looking at processes that are within or internal processes. So you can see here diagram 0 level at the 1 level, which is exploding this 1 right here into the processes that are within the 1. You notice that this has A, D, and then this has C out and C out. That's balanced too. So really what you want to have is when you have a balanced data flow diagram, which is one of the important things in constructing a data flow diagram, what you want to do is make sure that the inflows and outflows are equivalent if you're exploding internal processes. Here is a graphic of the Saprina current physical data flow diagram, and we started with a context diagram. We just looked at the table of entities and activities. This is where we have constructed the Saprina current physical data flow diagram. You can see it's balanced. It's got the same external entities as a context diagram. And then what you can see is that the activities that were, you've got the internal entities, and then after the internal entities are laid out, what you do is look at what those noun processes are, or what are those physical flows. So you start with a customer order data, and then you've got the customer order copies being sent back to them. And then from the sales rep, and remember in this example, the sales rep has a laptop that is not connected to the company's main computer. So the sales rep does a batch upload to the computer at the office. So you can see here the order data is sent or inputted in the sales rep laptop. Customer orders 2 copies. You got here where the daily orders are being sent from the sales rep laptop, goes to the mainframe or the main computer at the office, and then you've got the order entry clerk customer orders totals, begin requests to begin the processes. Down here is where all of the data is stored in the data stores, in the data store here with customer master, inventory master, accounts receivable, sales order, and then customer orders. And then finally, the 2 copies of the sales order are sent to the warehouse. So what you can see with a physical data flow diagram, it's showing how physically that data or the documents are flowing within the system. And that's why you create a physical data flow diagram, is to understand what those physical processes are moving throughout the system. So let's turn our attention to logical data flow diagrams. Logical data flow diagrams, what they're doing is, instead of physical, what you're doing is that you're processing, you're looking at the processes in data stores, and you're making a graphical representation of the system showing the system's processes, which are in the bubbles. It specifies what activities the system is performing without specifying how, where, or by. And remember, with a physical data flow diagram, it specified the how, where, or by, but didn't say what. And with a logical data flow diagram, it shows what. As I mentioned earlier, bubbles descriptives in a logical data flow diagram are verbs. So for examples, you're going to have receive, compare, capture, compares on there twice, so compare, compare. Logical data flow diagrams depict the system's activities, where a physical data flow diagram shows a system's infrastructure. So with a logical data flow diagram, you're looking at what the activities are. What are those things that, from a system standpoint, have to occur for some process to occur? And then with a physical data flow diagram, it's just showing the infrastructure and how the data and what that data is flowing within the infrastructure. And with a logical data flow diagram, you start with a level 0 data flow diagram, as we talked before, in order to be balanced. This is just a generic logical data flow diagram. You can see it's got the 2 external entities. And you notice that unlike the physical data flow diagram, which lists all the physical movement of data between the entities, this just shows how the logical part of the system flows. So you've got customer makes a payment, payment is received, so this is a verb. Remember, with logical data flow diagrams, it's a verb. You've got receipts, summary, you've got the clerk who compares cash and tape, you've got the sale recorded in the system, that sale goes to the data store, which is that sales journal, then you've got the validated receipts, prepare the deposit, and then the deposit goes to the bank. So you notice all of these are verbs that are going on within the logical data flow diagram, showing the logic within the system. I wanted to throw this up and just show just a really quick comparison between the physical data flow diagram and the logical data flow diagram for Saprina. And you can notice with this, just kind of a summary, you notice with the physical data flow diagram, it's showing the physical flow of the data within the system. And then you get over the logical data flow diagram. In this case, it is not as crowded. And it's not as crowded because you're not documenting all the individual flows of data into and out of the entities. You're just showing the logic that goes into processing, in this case, processing a deposit from a customer's receipt. So here are some guidelines that are from the book for data flow diagrams, for logical data flow diagrams. You got number 7, group activities if they occur in the same place and at the same time. For doing logical data flow diagrams, you want to group them together. Group activities if they occur at the same time but in different places. Group activities if they seem to be logically related. And to make a data flow diagram readable, use between 5 to 7 bubbles. And this gets into why you have the level 1, level 2, level 3 data flow diagrams. Start with a level 0 data flow diagram. Make it a goal to have between 5 to 7 bubbles in it, knowing that if you have additional processes that are going to occur, what you're going to do is have a level 1, level 2, level 3 data flow diagram to have the details of that. So this is the annotated table of entities and activities, and it's showing where I have come in and classified this table based on the entity that the activities take place in. And then what you do is that come up with just what is a summary of what those activities are. So you can see or group the activities as I put here. So one of the groups is 1.0, capture customers' orders, 2.0, record customers' orders, 3.0, record sales orders. This is a Saprina logical data flow diagram. And what has happened is you've taken these groups, and those groups are what these internal entities are going to be. And you start with, because it's one of the recommendations of doing a data flow diagram, that you start with your external entities, then drop in your internal entities. And then what you're going to do is come over here to what the activities are and drop these activities into the logical data flow diagram. So you start customer order, customer acknowledges the order. You've got notice these are verbs, capture customer order, sales rep customer orders file goes into the sales clerk's file. You've got here where the daily orders file, which is the batch file being sent to the main computer at the office, records customers' orders, goes into the customer order data store. That customer order data store goes into record sales orders in the system, which is the logical flow of this data through the system. And then you've got the updates to these data stores. And then when that is done, sales order acknowledgement is sent to the customer, and then a picking ticket. And a picking ticket is just where it is sent to the warehouse to tell a warehouse employee to pick those items to ship to the customer. So a summary of drawing data flow diagrams, kind of a big picture thing is don't let the rigor of documentation get in the way of using data flow diagrams to understand the system. What I hope to do in this class is give you a good foundation of creating data flow diagrams, because the odds are pretty high that whether you go into public accounting or whether you go into managerial accounting, you're going to have to be drawing data flow diagrams to understand the flow, whether you're evaluating controls or evaluating the processes. But don't let the documentation get in the way of using data flow diagrams to understand a system. Use your judgment when preparing a data flow diagram. One of the things that I've talked about in this class, this is not a debit and credit class, and there are more than one way to skin a cat. And when you do your homework assignment, you may prepare your data flow diagram differently from another student, and you may get the same grade, and it's because you just approach it differently. And part of that is using your judgment. And during this class, one of the things I want to do is help guide you through making judgments and preparing data flow diagrams. And here are a few issues that were not covered in the examples in class. One of them is number 11. A data flow should go to an operations entity square only when operation process functions are to be performed by that entity. A data flow should enter an entity bubble if the operations process entity is to perform an information process activity. So just take that for what it's worth. On a physical data flow diagram, reading computer data stores and writing to computer data stores must go through a computer bubble. So always have it go through a computer bubble. Don't miss that step. And that's part of using your judgment, and then also understanding what the rules are for creating a data flow diagram. On a logical data flow diagram, data flows cannot go from higher to lower level numbered bubbles. So remember, with a logical data flow diagram, always go from 1 to 2 to 3 and not from 3 to 1. And part of that is keeping in mind what the flows are, making sure that you put them in order with the table of entities and activities, and then numbering them within that annotated table of entities and activities, and then placing those within your logical data flow diagram. So let's talk about exceptions and error routines. And that's something that, from reading the book and from what I am about to talk to right now, is that in the processes in the book, we are not going to be documenting exceptions and error routines. But the reality of business and the reality of life is sometimes processes cannot proceed as planned. So you have to create exception routines and error routines to handle those required options that are out of the ordinary. And an example would be, and something that we covered in the last lecture, going through the context diagrams and how to document some of these activities, is you have a clerk that physically creates a total for the batch, and then their job is to compare that to the total within the accounting system. There are going to be times when those totals aren't going to match, and you have to have processes for covering those situations. And they're documented below the level 0 data flow diagram with a reject stub that indicate exceptional processes must be performed. Reject stub is a data flow assigned the label reject that leaves the bubble but does not go to any other bubbles or data stores. It's shown only in lower level diagrams. So you're not going to see the error routine except just an error routine documentation in a level 0 data flow diagram. To be able to see what the processes are when you have an exception or error, you have to go below that 0 level data flow diagram. And since this is online, if you have any questions, please email me or ask them at the first of class. Thank you for watching. I hope that this has helped prepare you for what we're going to do in the next class, which is roll our sleeves up. We're going to work in class problems, preparing a physical data flow diagram and a logical data flow diagram that's very similar to the homework assignment you're going to have. I'll see you at the next lecture. Thank you.